Hi everyone, and welcome to the first of two videos going through some past exam questions on the topic of qualitative analysis, or these tests for ions and things. So if we look at the first question we've got here, we've got a solution of calcium iodide, carried out a chemical test to show that the solution contained iodide ions, and there was a precipitation reaction. State the reagent that the student would need to add. Well, if we want to test for iodide ions, if we want to test for any sort of halide ions from group 7, then the reagent that we need is silver nitrate. Which is AgNO3. We wouldn't need to write both here, either the name or the formula would be fine. What observation would show that it did contain iodide ions? Well, they've told us it's a precipitation reaction. If you remember, testing for the halide ions, you add your silver nitrate and you'd get a white precipitate for chloride, a cream precipitate for bromide, or if it was iodide ions, you'd get a yellow precipitate. Write an ionic equation including state symbols for this reaction. Okay, so we're ending up with this yellow precipitate. It must have the iodide ions in it. What we're making is a precipitate of silver iodide. Okay, so we're ending up with a solid precipitate of silver iodide. That's because the iodide ions that are in the solution. Okay, remember, if it's a halide ion, they're group 7, aren't they? So they're just going to be a single minus ion. And therefore, if this is the formula of the silver iodide, the silver ions are just a single positive. Okay, and it is worth actually learning that. Silver is a transition metal, so it's not obvious what its ion is going to be, so it's worth just learning that the silver ions are just Ag+. And you can see why the state symbols are important here, because they're showing that these two ions from the solution are reacting together to make a solid, and that's why we get the precipitate. The student is provided with an aqueous solution of calcium bromide that is contaminated with calcium iodide. They carry out the same chemical test, but this time needs to add a second reagent to show that iodide ions are present. Right, so this is the problem of, yes, you've done the test and you've got your precipitate, but it's quite difficult to tell apart, is it a white or a cream or a yellow precipitate, unless you've got them side by side to be able to compare. He's done this reaction and you've got a precipitate, but is then looking at it going, is that yellow for the iodide or is that cream for the bromide? How do I prove that there are iodide ions present? Okay, well, remember that the way you can test for this is by dissolving it in ammonia. The chloride, the silver chloride precipitate will dissolve in dilute ammonia. The silver bromide precipitate will dissolve in concentrated ammonia, and the silver iodide precipitate won't dissolve even in concentrated ammonia. So that's what we can do. If we add concentrated ammonia, then you should find that if there is some iodide ions in it, it will have made silver iodide, and that precipitate will not dissolve, and that will show you that it did have iodide ions in it to start with. It was contaminated. So we want to add concentrated ammonia. Okay, here we then have some waffling about acids. We've got sulfuric acid. State the formula of two ions released when sulfuric acid is in the solution. Okay, so we're going to get the H+ ions from the acid, and then the sulfate ion is SO4 2-. A student adds a sample of potassium carbonate to an excess of sulfuric acid. Describe what the student would see and write the equation for the reaction. Okay, so we're going to see the solid potassium carbonate is going to dissolve into the solution. And we're also going to see some fizzing or effervescence, because the carbon dioxide gas is going to be produced. So then if we want to write this equation, we want our potassium carbonate is going to react with the sulfuric acid. We're going to end up making potassium sulfate. Now potassium's group 1, isn't it? So it's just going to be a K+ ion. We've seen the sulfate is 2-, so potassium sulfate is going to be K2SO4, and water and carbon dioxide. And is that balanced? Yes. Yeah. So just watch out, it is a 3-mark question, so that's kind of giving you a clue. If once you've done the equation, you probably need 2 observations, really. Okay, if we carry on with some other questions here. Right, it's saying chlorine reacts with group 2 elements to form some chlorides that are soluble. Okay, aqueous chloride ions can be detected by adding silver nitrate. We talked about that. The appearance of the silver chloride confirms the presence of chloride ions. What type of reaction is it? Well, if it's made as solid, then it's a precipitation reaction. Write the ionic equation. We saw this in the previous question, didn't we? So, and then we do need to put the state symbols in. So it's the aqueous silver ions reacting with the aqueous chloride ions to make the solid silver chloride. Okay, then says they're given a sample of an unknown group 2 chloride. Dissolved 2.86 grams of it in water, added an excess of silver nitrate, and they ended up with a certain mass of the silver chloride. Calculate the amount in moles of silver chloride that forms. Right, so what have we got? We've got the mass and we've got the molar mass. Okay, so the moles of the silver chloride is going to be mass divided by molar mass. So let's work this out. So we've got 8.604 divided by 143.4. 0.06. That's nice and easy for a 1 mark question. Okay, and then it says, deduce the amount in moles of the group 2 chloride that the student dissolves, hence deduce the relative atomic mass and the identity of the group 2 metal. Okay. Right, so this is actually a bit sneaky. We need to be a little bit careful. So we need to think about what we've done here. We want to write an equation, really. If it says deduce is kind of a key word that you can spot, right? They've used the word deduce here rather than using the word calculate. Notice that they used the word calculate here, so we had to do some sort of maths. If they use the word deduce instead of calculate, it means you're not using numbers they've given you to calculate it. Deduce means work it out through logic rather than doing maths. And usually it's you do that by doing the ratio from the equation. So if you see the word deduce, it's often, not always, but it's often to do with the ratio from the equation. So we need to write an equation here. If we had a group 2 chloride, we don't know what it was, but it would have been, if it was group 2, then it would have been magnesium chloride or calcium chloride or something, but it'll be like MgCl2 or CaCl2. So it'll be something Cl2, won't it? Okay, and we dissolved that, and we ended up making, so what we did is we reacted this then with, if we go up here, they reacted it with silver nitrate, didn't they? So they would have reacted that with silver nitrate, and it's going to make silver chloride, and well, it's going to make whatever it is, magnesium nitrate or something. So it's going to make XNO3 2. Yeah. So, and in terms of balancing it, we've got 2 nitrates, so that needs to be a 2, and we've got 2 chlorine, so that needs to be a 2. So the important thing here then is look at the ratio. It's a 1:2 ratio. So we know how many moles of silver chloride we had, so we're going to have half as many moles of our group 2 chloride, whatever it is. Okay. So the moles of the group 2 chloride is 0.06 divided by 2. That's what I mean by saying deducing it. You're not really doing a calculation. You're going, well, it's going to be half as much because it's a 1:2 ratio. So it's not obvious from the question that this is how you need to start. So it is worth, again, that's why it's worth looking at these types of questions. Now you've seen this, you go, okay. So now what are we doing? We know the moles, so therefore deduce the relative atomic mass. So if we want the relative atomic mass in grams per mole, we're going to need the mass. They've given us the mass up here. Okay, so we know what the mass of the group 2 chloride was. So we can say, if we do 2.86 grams divided by 0.03 moles, that's going to give us the relative, well, it's going to give us the formula mass of the compound, isn't it? 2.86 divided by 0.03. So we've got 95.3. So that is the MR of our XCl2, whatever it is. And then if we add up the Cl2 bit, okay, so run out of space here, the MR of Cl2, if we go from our periodic table, chlorine's atomic mass is 35.5, so Cl2 is going to be 71, isn't it? So the MR of Cl2 is 71. 95.3 take away 71 gives us 24.3. So that is going to be our X, whatever it is. Right, and we know it's something from group 2, don't we? So again, if we go back to our periodic table, 24.3 is magnesium. Okay. So the relative atomic mass is 24.3. Did say do it to 1 decimal place, so we're there. And the group 2 metal is therefore magnesium. And this is quite a common thing of, you don't know what element it is, but if you know the mass of the whole compound, you can take away the bit that you already know about and work out what the element is that's missing. Okay, this sort of concept comes up in quite a few different questions.